In this video, I'm going to explain how to graph piecewise functions. So here's an example. We've got f of x, then you've got that parentheses type thing, and it's equal to 3, where x is less than -1, and it's also equal to 2x minus 1, where x is greater than 2. So you see you have two equations there. So when it says f of x, what you really want to think of that as y equals. And think of it as we're doing two separate y equals equations. So the first one, where it says 3, I'm going to write y equals 3. I'm going to be graphing that line. Now, when it says y equals 3, think of it as y equals mx plus b form. Remember that if there's no x there, m is 0. The slope is 0. So when we have a slope of 0, that means we have a horizontal line. So y equals 3 is a horizontal line, and it's going to intersect the y-axis at that 3. So I'll put that right there on my graph. I put the dot, and then I'm going to draw that red line, the horizontal line, in. Later on, I'm going to be erasing, because the way with piecewise functions is that one equation will go for one part of the graph, and then a different equation will go for another part. But so right now, I'm just graphing that equation. And now I'm going to look at the x is less than -1 part, where it says that. And this means that I'm only going to be keeping that graph that I just drew where x is less than -1. So what does that mean where x is less than -1? Well, if you look at there's my x-axis down there. And I want to find where x, the coordinate, is actually -1. So I'm going to write there. I can see that's where x is -1. And what I want to do here to help myself is I'm going to draw a vertical line, just a dotted line, temporarily, straight up and down from that from where x is -1. And I'm going to see where it intersects that line that I just made, the red line. And now notice that it said x is less than -1. So that means that I'm only going to keep that y equals 3 red graph where x is less than the -1. So it could be where x is -2, -3. So everything to the left of that blue dotted line, because that's where x is -1. So when I do that, I'm going to get rid of everything that was to the right of that. And then as the question is, do I put a solid dot or do I put a open circle? So what that means is when it says, in this case, x is less than -1, it actually means that at exactly -1, that red line still doesn't exist. It's not right at that point where x is exactly on -1. So what we do is it's basically just less than the -1. So that means I'm going to put an open circle. That shows me that that graph, the red line y equals 3, is not starting, or it goes right to where x is -1, but it doesn't include that. So now moving on to the second equation, which is the 2x minus 1. Think of it as y equals 2x minus 1. So it's a line, and we know the y-intercept is -1, so I'm going to plot that there on the graph. And then I'm going to deal with my slope, which is 2, so the slope means it's 2 over 1. So from my red dot and the y-intercept there, I'm going to go up 2 over 1, up 2 over 1, and I'm going to backtrack. I might need it down here. I'm going to go backward, down 2, left 1, down 2, left 1. Okay, and then I'm going to graph that where it says, see, it says that only applies where x is greater than 2. So I'm going to do what I did before with the -1. This time I'm going to go find where x is 2. On the x-axis, I locate it there. And now I'm going to again draw myself a vertical dotted line temporarily. And then I see that up and down, and I see where that intersects the line that I just drew. And see where it crosses there looks like it's at about 2, 3. Okay, and so when x is when x is greater than 2, this line that I drew, the y equals 2x minus 1, will actually be drawn. Okay, actually, when I've drawn it now, I really haven't drawn it past x is greater than 2. So it's going to be to the right of that dotted line. So I need to do a few more points on that line, going up 2 over 1, up 2 over 1. Now I can just connect the line there. And now I'm going to go about erasing parts of it. So in other words, when I have x is greater than 2, that means that anything to the left of 2 is not going to be there. Okay, but it doesn't exactly equal, it's not true at 2, meaning 2 cannot be a coordinate on that line. So what I'm going to do, this is where I do that open circle thing. And I'm erasing everything to the left of x is 2. So it's only going to be right here where I start off where x is 2, and then that line continues forever to the right. And that is my piecewise function, so it ends up looking basically right like, clean this up, and that is the final piecewise function for the given function. Now that you've seen how to graph a piecewise function, I want to go back here and add a little bit of detail to that one to show you a little bit advanced one. In this case, what you can see that now I've added another equation there in the middle, and therefore I'm going to have three regions. And in this case, unlike the one I just did, they're going to kind of overlap. So you're going to have to really decide where one stops and the other ends, and the other one starts to come up. So going with the original one we had, which is the 3 there, which really means the y equals 3. So that's still that horizontal line we did. And we can just sketch that in. Remember, it goes through y is 3. It's a horizontal line. And then we know this applies everywhere that the x-coordinate is less than -1. So we draw that vertical line there representing -1. And so the graph is going to stay everywhere less than -1. And because it says less than, but not less than or equal to, I use the open dot. Okay, then I'm going to go on to the next one, which is the x plus 2, or negative x plus 2. That's the one I just added that I didn't have before. So that graph is going to be y equals the negative x plus 2 is going to have the y-intercept there of 2. And from there, I'm going to go to use my slope of a -1, or just -1 over 1. And again, so I'm graphing these and I'm erasing. This is the basic technique that you do when you start. So graphing that in there, I've got this line is going to go from 2 for the y-intercept, down 1, right 1, down 1, right 1. And then you might want to backtrack a little bit from the original that I did and go up 1, left 1, because it's the same thing. Now I'm actually hitting this one graph I'm doing right now, the negative x plus 2, runs right into that open circle from the first equation, the y equals 3. So this is where I really have to decide, okay, when I'm looking at the equation right now, the negative x plus 2, and notice how it says in there for the domain is that -1 is less than x, which is less than or equal to 2. -1 is less than or equal to x, and x is less than or equal to 2. Okay, so what does that mean? That means that because it's a solid, it's a bar there underneath, it means it's less than or equal to, right? So that's where we do a solid dot. So what ends up happening is actually fills in where the other equation didn't keep that value, where the y equals 3 had to stop and have an open circle. Right now, sometimes they'll give it to you where these overlap perfectly, and like this case where this second equation actually fills that dot in. And then I want to just connect the line there with those there. Okay, and we got to decide where it goes up to. So that region for this equation, the negative x plus 2, it's only between where x is -1 to where x is 2, or less than or equal to 2. Okay, so that we know that I put that. Again, I like to put the where I have the 2 there on the x-axis, the blue 2, and draw like a vertical line. Okay, and it's going to help me kind of where does this graph going to go to? All right, so we've got that line right there. That's where x is 2, that region. So I know I can draw my graph doing right now, right up down to where it meets that blue line. So that's where x is right on 2. And so the graph is going to exist. It can be equal to, so it's going to be a solid dot there, so I know that. All right, and now I've connected those dots. I've got that second line in there in the region between -1 and 2. So now I'm going to go on to the third equation, which is the 2x minus 1. So I'm going to graph that. I know that the slope is, or the y-intercept is a -1, and then I've got slope of 2 over 1. So putting this in there, I'm going to start with the y-intercept there at 1. Or -1, then doing the slope up 2 over 1, I get this sort of, do dotted line for now, and we get this shape. Okay, but again, this only applies every time you're past x is equal to 2 on the x-axis. Anywhere where the x value is greater than 2, you're going to be keeping that graph. So let's look at where that happens. I'm going to put I have the 2 there, and I'm going to, so when x is greater than 2, when x is greater than 2. And then we've got that, I'll put that blue line there so I'll know where to see where that blue line intersects that red dot from the equation I'm doing right now. That's where I'm going to start it. And then the graph is going to go this line is going to go everywhere keep going to the right. So there I've got that graph now, and just get rid of this Oh, since it's greater than, the problem is there's no solid dot there, so it's because it's just greater than, it's not greater than or equal to. So what are we going to do when it's not equal to? You're going to use that open circle, and there it is right there. Now I'm just going to clean this up. You can see what the result is here. This is where we've got the function is graphed, where all those three parts, and you'll notice with these, you're never going to, it's a function, so that means that you can never have you can never have one of your x values have different y coordinates. So the one I just did, it's an open circle at 2, x equals 2, and the middle graph there was a solid dot when x equals 2. So if both of them were solid, there'd be a problem. It can't be both solid, only one or the other. So you have to be paying attention to that.